Hello everyone and welcome back to the channel. The topic of today's video is the Hancitor malware. In this video, we will download the latest malware zip archive of the Hancitor malware from malware-traffic-analysis. From there, we will get access to the phishing documents. We will extract the macros from the phishing documents, which will get us access to the first DLL payload embedded inside the phishing document. We will analyze the first DLL to extract the second DLL payload from that DLL. And from there, we will analyze the second DLL payload to extract the final command and control details. So let's dive in. All right, so here I am in my virtual machine. This is my Remnix virtual machine where I will download the Hancitor with cobaltstrike payload. And this is from the malware traffic analysis website. I will leave the link in the description below. Let me download the documents and the DLL files. Press OK, and it will be downloaded. Let me go to the desktop, make a directory for Hancitor, move the file from the downloads to the Hancitor folder. I will cd into the Hancitor folder ls and unzip the file. File password is infected. All right. So once I've done this, I will stop here and I will go to the Windows machine and I will download the same thing there. I want to set a bit of context before I show you guys how to access and open the file, open the malicious Word documents using OLE dump. So let me cut this first. Take it to the desktop inside my Hancitor folder. I will close the browser and extract the same here as well. Again, password is infected. Open up the folder. The folder has other two folders inside it. One has the DLLs and the other one has the Word documents. We are going to be working with the Word document which ends in 252. So I will open up this document. And since this is a macro enabled document, it asks us to enable the contents. We are not going to do that. We will go to view and we will go to view macros. In the view macros, we will go to edit and we see all these macros here. Now I will discuss these macros in detail in the Remnix VM, but I want to show you guys something here. This is a function called y and it is called here in the document open function. This function here. Now, if you see here, these 3 or 4 lines are quite strange. It says that selection.move down to W line count 3, which means to the line 3. And then it says move right character 2, move down line 3, move right character 2, and then backspace, and then copy it. All right. So I want to basically explain what this is doing here before I jump into the Remnix VM and talk about the VB macros. If I close this macro here and I go to this document, it was talking about the third line. Let me go to the third line. I'm currently on the first line. Let me go to 1. It's on 1, 2, and 3. If you see this strange square here, let's see if I can expand this a bit more. There is a strange square here. If I right click on this and if I go to the package shell and then properties, the properties tell us that this is basically a DLL called kiks.dll, and it is basically an OLE object which is embedded inside this document. All right. And what will happen is that when the macro will open, this DLL will be saved on the system, most probably inside the app data, this folder. And then the malware macros which are embedded inside the document will be able to access this DLL and to run this DLL directly using the run DLL 32 functions. So this is basically the context that I wanted to set. And if you want to understand how to embed these kind of OLE objects inside a Word document, you have to go to insert, and then it's here object, and you go to object, basically create from file, and you browse, and then you add the OLE object here. All right, so now we are going to assume that we have some knowledge here of what is going on inside the document, and that knowledge we will go back to our Remnux VM, where we will use the OLE tools to analyze the document as well. So I have this folder here, and in it I have the Word documents. I will go to Word documents folder. I will go to the Word document folder, and the document that we are going to work with is this one, 252, which I said before as well. So let me do an OLE dump on 0617. It's going to be OLE dump.py. And in OLE dump.py, we can see that we have two M's here, which means these are the macros, and this is the object. It's an OLE 10 native object. So we are going to first dump this object. So select the stream, and then we are going to decompress it, and then we're going to dump this to dump.bin. All right, so that is fine. We have pasted this, we have extracted the dump.bin here, and now I'm going to move to the analysis of the VB macros. So in order to analyze the VB macros, it's very simple. Same command as before, just changing this to OLE VBA. So we have this. Now I'm going to dump this to vba.txt and open this in VS Code. So change the language here to Visual Basic. All right. And let me do just a bit of formatting here to make it a bit clearer. The formatting is complete. Let me start the explanation. I will start from document_open. In fact, let me start from here before document_open. We see that there is a function declared GC, which is an alias of shell execute A. So that means whenever GC is called, shell execute A will be called. We have a string, a global variable HDV also declared here, which would be currently empty. In the document.open function, we see a string declared rundle, which would, I think, be run DLL32 after it is concatenated with these two strings as well. And what this function is doing in a gist is that it is looking for the kikus.dll in the WD user templates path. If it finds this DLL, then everything is good. That means that it is already executing. If it does not find this DLL, then it calls this YYY function. YYY function, as we saw before, just copies the DLL to the temp path. After the file has been copied, it calls the HDHDD function. The HDHDD function just creates a file system object and calls the search get folder. This function is basically looking for the hxxps.dll inside the temp folders. So here it is basically looking for the hxxps.dll inside the wd temp file path. After it is found, it basically returns this in the PAFS string. The PAFS string is actually the HDV string which is passed here, which is in fact a global variable. So after this HDV contains the path of the DLL, then it calls the nam HDV function. The nam HDV function, let's see what it does. It is basically setting up the path properly. That's the only thing that it is doing. And after that, CVZZ has L3 and 2. So after these two are concatenated here, it will become run DLL32. And this GC is in fact the shell execute function. So basically all of this creates a shell execute function which will execute run DLL32 on the hxxps.dll file with this parameter. That's the basic gist of what this VBA function is doing. So now that this is complete, we will move on to the analysis of the dump.bin file on our Windows machine. So I'll see you there. All right, so now I have the dump.bin file saved on my Windows virtual machine. I will open this up in a hex editor. Basically, what we see here is that when we extract the OLE 10 document from the OLE dump, we do not get the actual executable. In fact, we have the actual executable, but it is appended with some garbage characters, which is this. So I'm going to delete these, and then the header will start from MZ. I will save it. After saving this, let me delete this back file, and I will drop this in PE Studio. In PE Studio, we can see that this is a DLL file. We have some exports here, but we do not have the export that we saw in our Remnux VM, which was this GBS LWS this. So I will show you how to reach this secondary payload as well. So go back, we can see all these exports here which are not relevant to what we need. So let me close this and let me just see if I can increase the display settings a bit. All right. So now the next step is that we have the dump.bin file, and then we have to move on to the analysis of this bin file as well. All right. The first thing that we do is that we will open this up in x64dbg. And the way to open up any DLL in x64dbg is to firstly open run DLL32. Then go to change command line. Here, let me replace this command line with In fact, let me place this on the desktop. And from there, I will pick out the path for the desktop. And use that here. You will use that. And instead of the DLL entry point, we are going to use the parameter that we had here, which is this one. Going back to our Windows virtual machine, paste this here, press OK, and then we are going to restart. All right. Now, hopefully we will start pressing play, and within 3 or 4 clicks, we should see the RDLL show up here, dump.bin. We have to enable some options inside preferences, which is DLL entry as well. So once that is done, let me go play 1, 2, 3. It will go again a bit. And then we have dump.bin here. All right. So we have dump.bin here. We have some old breakpoints enabled. Let me remove those. And let me put some fresh breakpoints. The breakpoints that we are going to put are, firstly, I'm going to go to G, follow expression, go to virtual alloc. And inside virtual alloc, I will go to the actual function, which is inside kernel base, and put a breakpoint on the return 10. The next breakpoint that I will be putting is going to be on virtual protect. Another one is going to be on resume thread. And I will also put one on virtual alloc x. All right. So once these breakpoints are there, these are the breakpoints that I have enabled. I will let it rip, play. So our first breakpoint is hit, which is inside virtual alloc. So let me put this in the dump, and we will start monitoring this. Play again. Now we can see that it has been populated with something. We have another breakpoint hit, which is the same one, and we have the position changed in EAX. Let me follow this in dump 2. Play again. And we see that this has been populated. We have this breakpoint hit again. And let me now open this in dump 3. We play again. And this time, the breakpoint that is hit is virtual protect. And we can see something which looks like an MZ header here. This is basically an encrypted header, but if we start going down, a bit, we will see the actual header embedded in it as well. So we should see it soon. So we have the MZ here, and this program cannot be run in DOS mode. So this is basically the unpacked PE file. So let's go to memory map, follow this in memory map, and we will dump this. And then I will show you how to extract this DLL from it. So go and save it on the desktop again. And we will open this up in hex. We have this encrypted header. We are going to search for our hex value, which is 4D5A. Press OK. And we have this MZ header here. I'm going to delete everything before it. And we now have a proper clear MZ header. Save this and close it. And we will delete this back file. So we have our two files. I can now bring this file inside my malwares folder. So this is our second payload. Dump.bin was our first payload. This is our second payload. Let us drop this inside PE Studio as well. If we drop this inside PE Studio, we can see that this file was compiled on January 18, 2021. We go to the exports and we can see, lo and behold, we can see this name which we saw inside the macro, which was trying to execute this DLL. So let me close this now and let me open it up in Ghidra. New project. I will say Hancitor. And I will import this file. Press OK here. Double click on this. This will take a bit of time to analyze, so I will resume the video after the analysis is complete. All right, so the analysis is complete. I will open up this export function. And inside this export function, we have only one method which is being called, which is fun10001870. I will open this. Inside that function, we start from the beginning. We have some local variables. Then we have this 1390 being called 3 times. I will open this. So this is getting the process heap, and it is allocating some data on the heap, or it is allocating some space on the heap. So let me rename this to mw underscore heap underscore alloc. So we know that these three functions are basically the same. Let's go into this one. And here we see a format string. So this gives us an indication that somewhere here should be the link which is going to be generated. The functions that are called are here. So let me go one by one. So this is a function which is being used to get the IP address details or the adapter addresses. It's nothing much here. Go back, nothing much here. Heap free. Getting the Windows directory and getting the volume information. So I will rename this function to say that this function is to fetch system details. Go back. So this was function system details, and this is a wrapper of get system details. So we have this function to get the system details. Let's move on. This is getting the computer name. And this is getting the token information. So let's say that this function is mw_get computer proc info, and so this is getting the computer and process information. We'll go back. So this is the next function which is being called. It is basically accessing this link to get the global IP address of the system. So that is fine. Let me rename this function to malware_get IP address info. And this is basically getting the DNS information. So this would be get DNS information. That's okay. This is the last one. It is basically getting the proc address of native system info, and you can basically look it up on MSDN. This function is basically used to get the system information. So I will rename this as well, mw_get system info. All right. And we have the last one before the format string. So hopefully this one contains some indication of how the IP address details will be fetched. So this is the first function, 1450. I think this is a string copy method. It copies data from here to here and it copies 2000 bytes. So I can rename this to str copy. The next one that we have is this. And this is basically a function which looks interesting, which might help us understand how the IP address details or the C2 details are being extracted. So if you look here, crypt acquire context A. So crypt acquire context A is here. So you can look at this function on MSDN. Crypt API is deprecated. So cryptographic providers. All right. So the third one, the third parameter here is the cryptographic provider here, which can be one of these. And then we have the flags. Okay, so the third one, which is this 0. Can I find symbolic constants? So set equate What can we do here? PROV. I think this is what it is. It's algorithm signature RSA. So the next one is script create hash, and then we have this. Let's look for this as well. Script create hash also has an algorithm ID, which is the second one. The algorithm ID would be, okay, so this will tell us what they are trying to do. It's 6801 is for RC4. Okay, so this one is SHA-1. And the next one is script hash data. Next one is script hash data. There are no further user equates here. Drive key. Drive key has algorithm ID on the second value. So let's go to 6801 and set it to equate. And we have RC4 coming up here. So this means that this is going to be an RC4 encryption and decryption function. So crypt, decrypt. All right. So I'm going to assume that this function is being used to extract the encrypted or decrypted details of the command and control, which are somewhere hidden inside this DLL. Now there are two ways I can go about extracting that information. Number one is basically I can try to follow along in the static code and try to find out the details from here. And after I do that, I can put this inside some Python code and try to extract the details from there. I will not do that today. I will try to find these details by running it inside the debugger itself. So let me try to show you guys how I do this. So copy this again to the desktop to make it easy to work with. Okay, so once the file has been copied to the desktop, I will open it up in x64dbg. Let me stop this, open run DLL, and I will change the command line. And the command line is, we just have to put the new name of the file. Press OK. We restart this once. All right. And if we press play a couple of times, we should basically jump into that DLL. So we are here now. Now, we can do something interesting here. We don't need to go and jump into all the hoops and try to find this function. We can just try to go back. go back and try to find this string. Since this string is in the clear, let's try to find whatever strings we can in this region. And we see that this is the string that we are looking for. If we go up, we should see the call somewhere close by. This is the call 25B0. And this is the one here, 25B0. All right. So we can press F2 and place a breakpoint here. I'll press play and hopefully we should jump here directly. We're in kernel base now. Yeah, so we are in 25B0. After we go to 25B0, we can go inside and we are looking for 2CD0. So go into, step into basically, and we're looking for 2CD0, which is this one. So press F2 here. And what we're looking for is this first argument. This first argument is basically a copy of this 5018, which we see here, C02EB5. All right. So let's press play and I will show you. Press play. We are here. We go to see this in the dump one, and we see this value here, C02EB506. Exactly the same thing. And this is basically the key, right? So hopefully what should happen here is that since this is the decryption function, after we step out of this function, we should see some data here, hopefully some C2 details. So let's come out of here, step over, and we see all the details come out, right? This looks like the bot ID for Hancitor, and these are the command and control details. We can see one link here, which is pipe separated. Then we have another link here and another link here. So I think that brings us to the end of our video. Thank you very much for your time, and I hope to see you in the upcoming videos.